Hello everyone, welcome back to my channel. In this lesson, we will model a complex hollow handle with raised surface features, completely in part design. We will also how to use Boolean tools, multi-section solid, shell, extract and thick surface in practical exercise.
I was dreaming in my sleep, now wide awake. With CATIA by my side, there's no mistake. Always had a wish to create and design. Now I'm building futures one line at a time. Could sketch a ship or design a plane. With CATIA, every dream I can sustain. Stay with me, I'll show you how it's done. Our journey to the stars has just begun. Dreams with CATIA come alive, stay tuned. In a world of possibilities, our talents boomed. From the sketch pad to reality, watch us soar. With every click and curve, we crave for more. From the smallest bolt to towering steel, with CATIA, our thoughts become real. Together we'll create wonders to see. In this world of design, just you and me.
Hello everyone. Today we are going to draw this shape together. A handle with some raised areas on its surface. The handle is a hollow part with a thickness of 2 millimeters. These kinds of parts are usually made in the Generative Shape Design workbench. But can we also create it in the part design workbench? The main and important challenge of this shape is the raised features on it. I want to create all parts in the part design workbench. Stay with me so I can show you the method of creating it. First, we check and define the origin and the coordinate axis. I place the coordinate origin at the center of the circle at the end of the handle. I consider the horizontal axis at the line perpendicular to the surface of the circle. I enter the sketcher workbench using the ZX plane. I draw a circle with its center at the origin at a diameter of 42 millimeters. I return to the part design workbench. I create a plane parallel to the ZX plane at a distance of 220 millimeters from it. I enter the sketcher workbench using this plane. I draw a circle centered at the origin. If you look at the drawing, you can see the value of 52 millimeters. But the drawing also shows a 2 millimeters fillet, so the diameter of my circle is 48 millimeters. I apply the dimension to the circle. I return to the part design workbench. Now I enter the sketcher workbench using the YZ plane. I want to draw the first guide curve. With the intersect tool, I get the intersection of the first circle with the YZ plane. Two points are created. The lower point is the one I need. First, I fully constrain it. I get the intersection point of the second circle with the YZ plane. I also constrain its lower point. Now I draw the following curve. I create an arc with a radius of 40 millimeters. I make one end coincide with the first point. I rotate the arc a little. I draw the second arc. The radius of the second arc is 210 millimeters. I make one end coincide with the free end of the first arc. I make the other end coincide with the point on the second circle. I make the two arcs tangent at their connection point. Now look, the distance from the connection point of the two arcs to the vertical axis is not given in the drawing. We must find this distance ourselves. I measure it in the DMU to the viewer workbench. I found it to be about 44 millimeters. For now, I use this value in the sketch. I look at the shape in the drawing and in my sketch. It seems a little out of proportion to me. I change the value to 50 millimeters. I activate the sketch analysis tool. I convert all unnecessary elements to construction geometry. I return to the part design workbench. Again, I enter the sketcher workbench using the YZ plane. I get the intersections of the two circles with the sketch plane. Now I work with the upper points. I fully constrain them. I draw a 3-point arc. The radius of the arc is 550 millimeters. Again, I use the sketch analysis tool to convert unnecessary elements to construction geometry. I return to the part design workbench. I activate the multi-section solid command. The tool settings window opens. In the first section, I select the two circles in order. I select the closing points correctly. The arrows on these 2 points must have the same direction. I must define the 2 curves as guides for the software. Why do you think I define these 2 curves in the guide section? I click OK. The shape is created. I check it. It seems that the end of the handle is a little thicker than it should be. I double-click the sketch on the first curve in the specification tree. I change the distance 50 back to 44 millimeters. I check the shape again. It becomes much better. Now I draw the front part of the handle. I enter the Sketcher workbench using the first plane that I created. I draw a central circle with a diameter of 80 millimeters. I return to the Part Design workbench. I extrude it with the Pad command. The extrusion length is 20 millimeters. So far, the handle has been created as a solid body. I activate the Shell command. I set the thickness to 2 millimeters. I click on the cylinder face with a diameter of 80 millimeters so it will be removed. I click OK. The shape becomes hollow. Now comes the difficult part. We must create the raised features on the surface. Learning this part will help you a lot when designing similar parts. For simplicity, I want to get a small help from the GST workbench. First, I create a new body. I enter the GST workbench with this body. We have a tool here called Extract. The job of this command is to extract a surface from the part. I activate it. I set propagation to tangency. In the Elements to Extract section, I click on the surface of the part. The handle surface becomes green. I click OK. Now I return to the Part Design workbench. Did you notice the method of moving between the two workbenches? Now I am in the Part Design workbench. I need a tool with the name of Thick Surface. This tool is located in the Surface Base Features toolbar. I activate the Thick Surface command. I set first offset to 2 mm. In the Object to Offset section, I click on Extract in the specification tree. I change the arrows to point outward. I click OK. I hide the part body. I rotate the model on the screen. Now a hollow tube with the shape of the handle can be seen. I hide the surface. I create another body. This body is active. I enter the Sketcher workbench using the YZ plane. I draw the curve shape of the raised feature on the handle wall. I place the edges of the curve above the handle. Its size is not important. I create the dimensions according to the drawing. With the offset tool, I create an offset at a distance of 5 mm from it. I close the ends of the two curves with two lines. I check my sketch with the Sketch Analysis tool. I return to the Part Design workbench. With the Pad command, I extrude the sketch from both sides by the required amount. The extrusion must be large enough to extend outside the tube surface. Now I activate the Intersect command in the Boolean toolbar. In the box next to the Intersect option, I click on Body 2. Body 3 is selected in the lower section. I click OK. The raised strip that I wanted is created. I unhide the part body. I activate the Add tool in the Boolean toolbar. In the box next to the Add option, I click on Body 3. The name of part body is shown in the box next to the 2 option. I click OK. The strip is added to the handle body. I check it from the front and top views. I want to create the strips on the handle surface. I create a new body. I enter the GSD workbench with it. I activate the Extract command. I click on the handle surface in the correct area. Part of it becomes green. I return to the Part Design workbench. I activate the Tick Surface command. I set first offset to 2 mm. In the Object to Offset section, I click on Extract in the specification tree. I click OK. For now, I do not unhide the part body. I want to check the position of the last strip. I create another body. I must create 4 planes parallel to the ZX plane. Their distances are 60, 90, 125 and 155 mm. I enter the Sketcher workbench using the first plane. I activate the Cut Part tool to get a better view. I draw a central rectangle. I draw the rectangle so that it extends completely beyond the sides and the top. Its lower edge is 11 mm away from the horizontal axis. I return to the Part Design workbench. With the Pad tool, I extruded 15 mm in the correct direction. I activate the Tritangent Fillet command. I round the lower edge of the block. I do the same thing on the next three planes. Notice that the lower edge of the second rectangle is 16 mm, the third rectangle is 21 mm, and the fourth rectangle is 20 mm away from the horizontal axis. I look at the last block from the side. There should be no interface between it and the first strip. Now I hide the part body. I activate the Intersect tool from the Boolean set. I select body 4. Body 5 is automatically active in the box below it. I click OK. The strips are created. I activate the Add tool from the Boolean set again. I select body 5 in the first box. The name part body is shown in the second body. I click OK. Now I unhide the part body. The shape is complete. I check it from different directions. Finally, I create two fillets. The first fillet is 2 mm and the second fillet is 4 mm. Very good, today's lesson is finished here. In this exercise, you also became familiar with some new tools. We used the Boolean tools effectively. You saw how useful and powerful this tool is. Goodbye until the next lesson.
Let's build